Okay, 5.2 day 2, we're doing properties of rational exponents. Although these are the same properties of regular exponents, we're just including rational exponents while we try out the properties. Okay, so the first property, if you multiply two monomials with the same base, we add the exponent. So if I was doing 2 to the second times 2 to the third, since they both have a base of 2, I can add the exponent, so 2 plus 3, which is 5. And then I could evaluate it from there. 2 to the 5th is 32. Okay, the next one, I can do the same thing. I'm multiplying two monomials, and they both have a base of 5, so I can rewrite this with a base of 5. If I add the exponents are the 1/2 and the 3/2. If I do 1/2 plus 3/2, I add the numerators, I get 4/2. Okay, now because 4 divided by 2 comes out so nicely, let's make it 5. 4 divided by 2 is 2. So 5 squared is just 25. Okay, let's look at this one. Since they both have a base of 7, I can rewrite this. I'm going to add the exponents. If I do 5/3 plus 4/3, I get 9/3. And we do know what to do with fractional exponents, but since 9 divided by 3 is just 3, let's make it 7 to the third. And then I can evaluate that with my calculator, and I get 343. Okay, let's look at the next property. The next property says if I have the product of a times b to the m, I can distribute the m to both of them instead of doing each one individually. It sometimes makes it easier, it sometimes doesn't, so we're going to try it so that we know we can do it. Even though it's not always easier. So in this case, we could do 2 times 3, which is 6 to the third, but let's try to distribute the exponent. So since this 3 exponents to 3, I'm going to bring it down to here and here. So this is going to be 2 to the third times 3 to the third. 2 to the third is 8. 3 to the third is 27. 8 times 27. Putting it in my calculator, 216. Okay, and I don't know that that was faster way than doing it the other way, but it would also work. Okay, now if I look at this one, if I do 36 times 49 and then I raise it to the 1/2, I don't really want to do 36 times 49. So instead I'm going to distribute the 1/2 power. So if I do 36 to the 1/2 times 49 to the 1/2, does that make it easier? It kind of does, because 36 to the 1/2 is really the square root of 36 times the square root of 49, which is 6 times 7, which is 42. Let's try it on the next one. I could do 64 times 27 first, but I don't really want to because that's going to be an enormous number. So let's try to do 64 to the 1/3 times 27 to the 1/3. So this is the third root of 64 times the third root of 27. The third root of 64 is 4. The third root of 27 is 3. So this is going to be 12. So I don't think it made it easier for the first one, but I do think it made it easier for the second two examples. So sometimes we're going to decide which one's easier. Okay, let's look at this one. Okay, this is the same. I'm kind of distributing the n. If I do a to the m to the n, I can multiply the exponents and make it a single entity. So if I do 2 squared to the 5th, that's 2 to the 2 times 5, that's 2 to the 10th, and then I can put 2 to the 10th into my calculator. I got 1024, 1024. Okay, now on that particular one, if I had done the exponent first, it would have been 4 to the 5th, and I should get the same answer, so it didn't really make it much better. Okay, for the next one though, this is 5 to the 1/3 to the 6th. I don't know 5 to the 1/3, so in this case, I do want to multiply the exponents. Okay, if I do 1/3 times 6, what do I get? I get 6/3. I'm okay with fractional exponents, but 6 divided by 3 is actually just 2. So it's much nicer for me to make it an integer, because I know 5 squared is 25. Let's try the next one. Okay, 4 to the 2/5 to the 5th. So if I do 2/5 to the 5th, 2/5 times 5 is 10/5. 10 divided by 5 is just 2. So 4 squared is 16. Okay, and if you multiply the fraction in your head, you could skip this step and show this step, but do show the middle step so I can see you're using the properties. Okay, now we're going to do a negative exponents, which we already know. If you have a negative exponent, it moves the base to the other part of the fraction, so it normally makes a fraction, and then we can evaluate it from there. So this is 5 to the negative 2, so that's the same as moving the 5 to the denominator, so I can make it a positive 2. That's 1. So I get 1 over 25 as my answer. Okay, I can do the same thing with 49 to the negative 1/2. I can, if I take care of the negative exponent first, this becomes 1 over 49 to the 1/2. Okay. 49 to the 1/2 is the square root of 49. So I end up with 1 over 7. Let's try the next one. 27 to the negative 1/3. Since it's a negative exponent, I can move it to the bottom now. Okay, if I do 27 to the 1/3, I'm doing the third root of 27. So I get 1 over 3. Okay, let's look at the next property. The next property is if I do something to the 0, I get 1. And this is only true when a is greater or equal to 0, or less than or equal to 0. It just can't be 0. Okay, so what does this tell me? It says if I do 213 to the 0, what do I get? 1. Now if I do 3/5 to the 0, I still get 1. Because the whole thing's in parentheses. Okay, what if I have 3 squared, 5 to the 1/2, 7 to the negative 2 to the 0? I mean, I could distribute the 0 to each of these things, or I could say this whole thing to the 0 equals 1. Okay, a couple more properties. Okay, this one, a to the m over a to the n. I subtract the exponents if they have the same base. So 6 to the 7th over 6 to the 4th. Since they both have a base of 6, I'm going to keep it a 6. If I do 7 minus 4, I get 3. And then 6 to the 3rd, I believe, is 216. Okay, I'm going to do the same thing with the next one, but even though it has fractional exponents. Okay, so they both have a base of 6, so 6. If I do 5 halves minus 1/2, what do I get? I get 4 halves. Okay, which still has a fraction, but 4 halves is just 2. So this is really just 6 squared, which gives me 36. So it comes out nicely. And let's try another one like this. These both have a base of 9. Okay, I want to do 7 halves minus 3. Ooh, they do not have a common denominator. We got to make them common. So I want to make this over 2. So I need to times by 2 over 2. So I get, what is that? 7 over 2 minus 6 over 2, which is 1 over 2. So I have 9 to the 1/2. What is 9 to the 1/2? Well, that's the square root of 9, which means my answer is 3. Okay, last property. Okay, if I have a fraction in parentheses raised to the m, I can distribute the m to the numerator and denominator and get my answer that way. So that means that if I do 3 over 5 to the 3rd, that's really just 3 to the 3rd over 5 to the 3rd, which is 27 over 125. Let's try it on the next one. Okay, 25 over 49 to the 1/2. That's the same as 25 to the 1/2 over 49 to the 1/2. Okay, 1/2 is a root, so this is the square root of 25 over the square root of 49, which gives me 5 over 7. Okay, one more. Okay, 8 over 27 to the 2/3. So I'm going to go ahead and do the top and bottom separately. So 8 to the 2/3, 27 to the 2/3. Okay, what is that? That's the third root of 8. Then I'm going to raise it to the second over the third root of 27. I'm going to raise it to the second. What's the third root of 8? Third root of 8, that's 2. Raised to the second. What do I have on the bottom? Third root of 27 is 3. Raised to the second, so I'm going to get 4 over 9. Okay, so go ahead and try your homework. You want to use these properties to make it easier for yourself to evaluate different expressions.